All right, welcome back, class. We're almost on the last section, but I think this might be the last section. I just have to double check. I think it is, but we'll see. Anyways, 5.5 we talked about long division and synthetic division. Okay, and that was we learned about synthetic division when we were talking about synthetic substitution. So I told you that was the one that was important. That's also going to be coming up in this section too. So again, first one, go ahead and divide using long division. Second one, you have to use, well, you don't necessarily have to use synthetic division, but remember synthetic division only works when there is the power of 1. You could also use long division for that too. But again, synthetic division is the one that you want to master for this section as well. And last, same thing. If they give you that this is a 0, we talked about that, go ahead and use synthetic division and go ahead and find me the other zeros. So again, we're going to start tomorrow in class with the warm-up. And again, I'm just going to call on 3 random students to come up and do these examples for us. All right. So today we're actually going to learn what happens if I give you a polynomial function and I don't give you any zeros. How the heck are we're going to solve it? Like, is there something out there that we've learned, or are we going to learn how to solve a polynomial function? And there is. There's actually a theorem for it. Okay. All right. So today, again, we're going to find all the possible rational zeros. Okay. And here's the famous theorem. So the rational zero theorem just states, okay, and again, we've seen this before. This is just a generic form of a polynomial function. It's just saying that if I start with something like x to the 5th, you're descending, next comes x to the 4th, x cubed, x to the 2nd, x to the 1st, so on and so forth, until you get to your last term, which is your constant. Okay? So what this theorem is saying is that you could take any polynomial function, take the last term, and take the factors of the last term divided by the factors of the first term, the leading coefficient, which we talked about in section 5.2. So again, I'm always referring back to this section just so that you understand that math, we're always building on one subject, on one topic, on another topic. All right, so our P is going to be our last constant, and our Q is going to be our leading coefficient. Okay, and we want to figure out what the factors are. Alright, so here are 5 examples, and again, if you can't really see some of the examples, again, I'll give you guys a printout tomorrow in class. But let's go ahead and get started so we see what this looks like. Alright, so again, it says list the possible rational zeros of the function using the rational zero theorem. Okay? So first, I want you to be able to identify P and Q. So looking back on the theorem, P is always going to be your last constant, and Q is going to be your leading coefficient. Okay? But there is no leading coefficient, but there is. It's a 1. Remember? Because 1 times anything is itself. So we have this formula, P over Q, 16 over 1. And now you have to list out all the possible factors of 16. Okay? Just so that you know, you don't have to list out the negative, just because at the very end, all your answers are going to be plus or minus. Okay? That takes care of the negative possible factors. So list out the possible factors of 16. We have 1, 2, 4, 8, and 16. And we're dividing by 1. And again, hopefully you all agree that if we divide all these numbers by 1, 1 divided by 1 is equal to 1, 2 divided by 1 is equal to 2, 4 divided by 1 is equal to 4, so on and so forth, we get the top. So our possible solutions are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, plus or minus 16. Okay? And again, where did I get the plus or minus? Because how can we get 16? We could get 16 by negative 1 times negative 16. This covers all your possible factors. So there's no need to list all positive and negative. Just make sure to put plus or minus at your very last step. And that covers your plus or minus. Okay? So this right here are my possible answers. How many do I have? Well, count. 1, 2, 3, 4, 5. 5 times 2 is 10 possible answers. So yes, students don't like this section because you have to actually guess and check. Okay, but I'm going to give you a rule of thumb. And remember, the rule of thumb just means that every time you come across a certain situation, you're going to always do that situation. So in this case, the rule of thumb is you always want to start with plus or minus 1. Okay? 90% of the time, plus or minus 1 works. If it doesn't, then you want to go in order or start with your fractions. Okay? We are going to have fractions that we're going to see in the other examples. Okay? All right, I'll let you do number 3. Number 4, I'll go ahead and do let's go ahead and do number 5. Let's put number 5 up here. We have 9x to the 5th plus 3x cubed plus 7x minus 4. All right, so same steps. You want to list out your P and Q. So P again is your last constant. And now we have a leading coefficient of 9, which is going to be your Q. So let's go ahead and list out all the possible factors of P and Q. Now you're going to say, Mr. Mira, what happens when we have a negative 4? Again, I told you that the plus or minus over here covers all the possible factors. So let's go ahead and just list out the possible factors of 4. Okay? So possible factors of 4 are 1, 2, and 4. Possible factors of 9 are 1, 3, and 9. Okay. So this one's a little bit different because we have 3 numbers to divide by. Okay. So let's go ahead and divide 1 by 1. So 1 divided by 1 is just plus or minus 1. 2 divided by 1 is plus or minus 2. 4 divided by 1 is plus or minus 4. So that gets rid of the 1. Okay. I'm going to put a little slash through it. Next comes the 3. 1 divided by 3, we cannot simplify, that's 1/3. 2 divided by 3 is 2/3. And 4 divided by 3 is 4/3. Okay. So that gets rid of the 3. We're almost there. Next, we're going to try the 9. We get plus or minus 1/9. 2 divided by 9 is plus or minus 2/9. And lastly, 4 divided by 9 is plus or minus 4/9. So these are our possible solutions. There's 9 of them times 2. That's 18 possible solutions that we have to try. But again, remember the rule of thumb for these. You want to start with +1 or -1. If not, then you want to get started with your fractions. Or you could just go in order, okay? If you have all that time, okay? But again, no one has that much time to go through 18 possible solutions. Okay? All right, so this is gonna lead us into actually solving these polynomial functions, because we're gonna have to actually guess and check. And how are we gonna check? We're gonna use synthetic division, okay? All right. Alright, so I did number 5 for you, I did 1 for you. Go ahead and do 2, 3, and 4, and again, same like always. I'm going to have 3 volunteers come up and do 2, 3, and 4 for our participation grade. Alright, so let's go ahead and get into the other stuff, which is solving. Okay. How do we find all the real zeros of the function? So we have to use the rational zero theorem, okay? Which says that we have to use P over Q. So let's go ahead and get started with number 6. All right, so your first step is to tell me what P and Q are. So P is -8. Q again is 1, which is our leading coefficient. So P over Q gives me -8 divided by 1. So we're listing all the possible factors of negative 8. Okay, so I'm just going to list the positive ones: 1, 2, 4, 8. And when I put plus or minus, that takes care of the negative. Okay. So we get plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. Okay. All right. So if you don't understand what I mean by that takes care of the negative, well, how do we get negative 8? We get positive 1 times negative 8, which is there. And vice versa. How do we get negative 8? We get negative 1 times positive 8. So that's what I mean. If you just put plus or minus at the very end of your answers, that takes care of all the positive and negative factors. Okay. All right. So what is my rule of thumb? I'm going to go ahead and try 1 and negative 1 first. So let's go ahead and try 1. And remember synthetic division. We multiply on the outside. We add on the inside. Okay. What are we adding to? Well, we have to go back to our original polynomial function. So the leading coefficient is a 1, so I'm going to bring down the 1. Then it's negative 7. Then it's 14. Then it's negative 8. Okay. Now, the reason I went ahead and wrote these leading coefficients is because it's a standard form. It goes 3, 2, 1, then 0. Okay. So in order for this to work, you have to drop down the first power. And let's go ahead and get started. 1 times 1 is 1. 1 plus negative 7 is negative 6. Okay. Now we have two numbers on the outside. 1 times negative 6 is negative 6. 14 minus 6. 14 plus a negative 6 is still negative 6. Gives me positive 8. 1 times 8 is 8. And we get 0. This is what I want. You want to get 0. If you don't get 0, it doesn't work. That means that it's not a factor. Okay? That this number right here is not a 0. It's not a factor. It's not a root. Okay? All right. So I told you, like before, these numbers actually mean something. Okay? We're dividing a polynomial function of a degree 3 by a polynomial function of a degree 1. Okay? So therefore, this one's going to be x squared minus 6x plus 8 equal to 0. And why am I setting it equal to 0? Because they want you to find all the real zeros. Okay. All right. I already taught you box method for like two chapters already. So again, I'm just going to use mental math. Let's go ahead and move to the middle. Again, you could double check my math by using box method, but how do we get two numbers that multiply 8 when we add them or subtract them? Give me negative 6, that's negative 4, and negative 2. Okay. Zero product property means when you multiply two numbers times 0, one of them has to be 0. So let's go ahead and add for x, or let's go ahead and solve for x, not add for x. So x is equal to 4. And x is equal to 2. Okay. So now you're going to list out the possible zeros. X is equal to 4. X is equal to 2. And you're going to say, wait, Mr. Burrow, what happened to the last one? Well, if you look over here, we actually found our first zero, which is 1. Don't forget about that last answer. And how do I know that I have to get 3 solutions? Well, remember, we look at our highest power or highest exponent, which is 3. That tells me that this polynomial function has up to 3 solutions. And in this case, it does. Okay. All right. Go ahead. All right. So that was number 6. Let me go ahead and solve one more. Let's go ahead and do number 8. So we have f of x equals 3x cubed minus 17x squared plus 18x plus 8. All right, so first step, you want to list out your possible P and Q. Okay, so we have P over Q gives me 8 over 3. So you want to list out all the possible answers for 8, which are 1, 2, 4, and 8. And for 3 is 1 and 3. Okay, so remember, you have to go ahead and divide. So 1 divided by 1 is going to be itself. So I'm going to go ahead and write the top. That covers the 1. And 1 divided by 3 is 1/3. 2 divided by 3 is 2/3. Then 4/3, and the last one is 8 over 3. Okay. All right. So remember, the rule of thumb is go ahead and plug in plus or minus 1. So let's go ahead and do 1. And again, our goal is trying to get 0. If we don't, then we move on to the next number. All right. One times 3 is 3. That gives me negative 14. 1 times negative 14 is negative 14. That gives me 4. And what do you know? It doesn't work. Okay, so let's go ahead and try negative 1. So this is, well, this stays the same. Okay. Negative 1 times 3 is negative 3. This will give me negative 20. Negative 1 times negative 20 is 20. And that's not going to work either. Okay. So our rule of thumb failed. So let's go ahead and try positive 2. Okay. If we try 3, 3 times 2 is 6. This will give me negative 11. 2 times negative 11 is negative 22. This will give me negative 4. And 2 times negative 4 is negative 8. Okay, so I got it on my 3rd try. Okay. All right. Again, these numbers actually mean something. So you get 3x squared minus 11x minus 4 gives me 0. Okay. All right. So I'll leave it there. I'll go ahead and finish this one in class tomorrow. I want to actually show you what your homework is. So let me go ahead and pull that up. So here is your homework. So go ahead and work on the following homework assignments. I might change it, but I'll let you guys know tomorrow. Okay? All right, Mr. Mira out.